All right, hello everybody. So today we're going to talk about factoring special polynomials. So it makes these specials that we're using a difference of squares here. So what I mean by that is that we have two squares, x squared, and let's say a squared number like 25, and we're going to take the difference between those. Okay, so we have this kind of situation for all of our difference of squares. These are special kinds of polynomials. And that's just because we got a square here and a square here mainly. So remember, to get a square for our x, we have x times x. And to get a square number, you would have a number times itself. So for 25, we have 5 times 5, and that's how we get 25. So squares are going to be any number times itself. Okay, so with these special polynomials, there is a pattern to solve these, but before I show you that, I just wanted to go through how we factor these normally so that you could clearly see how we can get the pattern, okay? So before we do anything, we usually label these. So we know we have an A, and here we only have two terms. So we're either missing a B or a C here. We know that this is going to be C because this is just a plain number. That is a constant. Our B usually has a X on it. So since we don't have a B in this problem, that means our B is going to be 0. Okay? All right, so we're going to factor this like we usually do with our x. A times c is going to go at the top. So we have 1 times negative 25, so that's going to be negative 25 at the top. At the bottom is our b, but we just said that b was going to be 0. Okay, same as usual, we're still going to multiply these. Sorry, we're finding two numbers that multiply to give the top, which is 25, and then add together to get the bottom. So to do that, I'm going to do my factor tree. Let's see, 1 times 25, and then 5 times 5 are the only two numbers that'll work here. Okay. Looking at the top, I see that we have a negative number, so that means we're actually subtracting our two numbers to get to 0. So 5 minus 5 will work to get to 0. And then from here, we could just write our answer, x plus 5, x minus 5. Okay, cool. So with these specials, like I said, there was a pattern. Now, we took x times x to get to x squared. We took 5 times 5 to get to 25. So what we can do with this is take our square root of each piece and then just put that directly in our answer. So we had 2 x's here. So I put 1x in this problem, and then 1x, oops, that didn't go right. 1x here, and then the other one went right here. Cool. We had 2 5s. 1 5 went in this problem, 1 5 went in this one. So we're just taking our x and our 5s, and then putting a plus sign or a minus sign between them. And that's really all we need to do for these problems. Instead of having to go through the entire process of drawing our x and going through that, we could just do it this way. So to like extra emphasize this, let's do another problem. Let's do x squared minus 49. Okay, so I know that x times x will give me x squared. I know 7 times 7 will be 49. So from here, I could just directly write my answer. So I have an x. Both of those are going to go inside of my parentheses. X, x. Okay, we're going to take these 7s, and we are also going to put those inside of our parentheses, right here and right here. Okay, now we just need one to have a plus and one to have a minus, and we're done. We are good. That is the end of the problem. That is our answer. Okay, let's do one more. Let's do x squared minus 121. Okay, so I know it's going to take me 2 x's multiplied together to get x squared. Now let's see. 11 times 11 will get me 121. Cool. All right. So directly into my answer now. I'm going to grab an x, put one in here and one in here. I'm going to grab these 11s. One is going to go in there. One's going to go in there. I need one to have a plus. I need one to have a minus. And that's it. We're done. So, important part here is that we only have squared numbers and variables here. This only works with stuff that is a perfect square. If you had like a 3 in here, that wouldn't work, because to get to 3, you would need to have 1 and 3, and those are not the same, so that doesn't work. It has to be a squared number. Okay, so these are going to be our first type of this problem, so I'm just going to say this is type 1, and then we're going to add on to that. So let's do a type 2 problem. Type 2 problems would look something like this, where we would have an extra number on the outside here. So our A would be something different. Our A would not be 1 this time. But it is still a squared number, because 3 times 3 gives us 9. And we still have x times x, and then 64 is going to be 8 times 8. So this is still a squared number. So our trick will still work here. So let's see, we got 3, we got x, we got 8s, and then we need a plus and a minus. Cool, so still works the same way. We could see that again. Let's try 16x squared minus 36. Okay, let's see, 4 times 4 will give me 16. X's again, and then 6 times 6 will give us 36. So using my parentheses, I'm going to take my 4s, put those first. Oops, no, not where I wanted that to go. One here, one here. There we go. 4s, x's come next, 6's go last, and then we have a plus or minus sign. And you're just going in order with these. We had 4s, x's, 6's, 4s, x's, 6's. Same thing. Same order that it goes in. Okay, so these ones are going to be called a type 2, and that's just because it has an extra number than type 1. Okay, so we do have a type 3 with these problems, and the type 3 ones are not going to start out the right way. Our type 3 problems will not start out with squares, and so we're going to have to change it so that they are squares. So for example, let's say we have 3x squared minus 75, okay? 3 is not a square number, and neither is 75. So we're going to need to change this so that we do have a square. So to do that, we're going to need to take something out. We could take out the greatest common factor, or the GCF. So this is what we did last week. So take out the GCF. What is the GCF? Well, usually it's just going to be that first number there. So I'm going to divide by 3 for both of my pieces, because I'm going to take that out. And let's see, 3 divided by 3 is going to be 1. I don't need to write a 1 though, so I'm just going to have x squared. And then 75 divided by 3 is going to be 25. And if you're not sure, just use a calculator. Cool. All right, so if we ignore this 3 for a second, we have x squared minus 25. Okay, so that is a difference of squares, because we have x squared minus 25. That is a type 1 problem. So what we can do is just answer what's inside the parentheses first, because I got, let's see, 25. That's going to be 5 times 5. So I'm going to have x plus 5, x minus 5. And then this 3 is just going to come straight down. We're not doing anything with that. We're just bringing it down. So then this, oopsies, wrong color. This would be our answer for that problem. Take out your GCF first and then use your trick for the specials. So let's try another one. Let's do another one. Let's do 2x squared minus 72. Okay, so I know that 2 is not a perfect square. I also know 72 is not a perfect square. So that means we have to take out that GCF. Usually, like I said, it's going to be that first number. So divide that out of both pieces. I am going to have an x squared again. And then 72 divided by 2 is going to be 36. Cool. So if we ignore this part for a second, we can just do our trick with our squareds because we have x squared minus 36. Okay, so I know that 6 times 6 will give me 36. So if I factor that, that'll be x plus 6, x minus 6. And then this 2 is just going to come straight down. Cool. And that will be our answer. Okay, let's do that one more time. I have 5x squared minus 80. Okay, so I know 5 is not a perfect square, neither is 80. So that means I'm going to have to take out my GCF. When I do that, I'm going to be left with x squared minus 80 divided by 5. That's going to be 16. And then if I ignore this part, I can do my parentheses first. So I know that 4 times 4 will give me 16. So if I factor that, I have x minus 4, x plus 4. And that 5 is just going to come straight down. So that's what I have for those. Okay, so these are 3 types. Oops, I need to label this one. This is our type 3. Cool. All right, so this is what we got for this trick. Remember, this only works if you have something that looks like this, where it's a difference of squares, where it only has those 2 terms in it. So just be careful with these, but that's all I got for you with these notes today. I hope you have an awesome day. If you have questions, let me know, and I'll see y'all later. Bye.